We're here in the building of a planned maintenance customer to finish the maintenance on 3 boilers today. These are Viessmann Vitodens 100 series boilers, 530,000 BTU an hour input each, and we installed these about 3 years ago. We've done the maintenance ever since. You can put these on a rack system, which these are, and connect them all together. We're using a staging module which ties all the boilers together. This actually shows you a lot of the settings, but briefly it's showing right now 2 boilers running and giving us the modulated input of one at 205,000 BTUs an hour, second one at 206,000 BTUs an hour, and another one at 0. This control is used to stage all the boiler operations, turn everything on and off, warm weather shutdown of the main system circulator, and give us all the high efficiency control we need to stage things properly to get maximum energy efficiency and cost savings out of these boilers. Take a look at the back of the rack just to show how it's mounted. This rack is actually the water sections for this boiler. So the main circulator pump on this system pumps in and out of this, what Viessmann calls their low loss header. This is the hydraulic separator unit. We have return water from the system out in the building, coming back here. Supply water going out to the system goes this way. We have an air separator. The boilers have their own circulator pumps, and they each pump in and out of the tube manifolds that are part of this rack. Return water to the boilers. Cooler water comes back here. Heated boiler through here to be distributed to the building. Most common problem we have with these Viessmann boilers is that very few owners want to allow us the time to do the proper maintenance and service because they seem to just keep on running. So we have to do our due diligence and make sure that they understand that just because a system's running doesn't mean it doesn't need maintenance, doesn't mean it doesn't need to be checked on an annual basis. A couple of important things we want to check on an annual basis is the condensate drain on the boiler. If it becomes plugged, it's going to fail to work. On this boiler, you can see that there's a piece of gray plastic polypropylene that comes out of the bottom of the heat exchanger. This is the drain for the condensate coming out of this boiler vessel. Down in the bottom underneath, kind of hard to get to, but you can see that it sticks down out of the bottom and has a cap on it for cleaning, so that we can just open it up, make sure that it's not plugged, make sure that the condensate's able to drain out of this. One other important thing on these boilers, high efficiency units have condensate that comes out of them at a pH of about 3.8. So it's acidic condensate. You don't want to dump it down old floor drains and cast iron drain systems without having a neutralizer unit on it. So we always make sure that there's a properly sized neutralizer unit to take all the condensate from the full capacity of the boilers, and that needs to be checked annually too, to make sure that the neutralizer pellets in it aren't all neutralized and gone. Another extremely important item to check on an annual basis is the heat exchanger itself and what it looks like inside. We can check the igniters and flame rods by pulling them out without pulling the whole cover off of the heat exchanger, but we want to examine the heat exchanger and the burner, look at the condition of those, and properly clean them to make sure that this boiler stays in good condition. A high efficiency boiler neglected for as little as 5 or 6 years, you can literally compromise the whole life of the boiler and need to replace it. This should last a good 25 or 30 year lifetime if we do the proper maintenance. So we're going to disassemble this, take a look at it, do the proper cleaning, and see what condition it's in. So in order to inspect the heat exchanger, we've got to disconnect the wiring for the flame rod and igniter. We have to disconnect the wires from the gas valve, and then we have to go behind and disconnect the gas line coming into the mixing portion here between the gas valve and this venturi. Now that we've pulled the front of the heat exchanger plate off, we can inspect the burner. We can actually take a look at the flame rod and igniter from here. We want to inspect the gasket on here to make sure it's going to be okay when we put it back together. They're usually good for a couple years, and taking them apart and putting them back together a few times. And make sure that the quality of the refractory here is good, that it's not cracked or missing pieces. Everything looks okay. We want to take a look inside the heat exchanger. We also want to make sure that the refractory at the back is good. This is not a wet back boiler, so it's important to have that there so that we don't burn through the back of the firing chamber. And then we want to look at the tubes in here, see how much debris is here. And even when there's not a buildup on the surface, sometimes down in between you can get enough that we want to make sure that we go down there with the special tool supplied by the manufacturer to actually brush it out, clean it out, and make sure it's clear. So we're going to use this. We're going to go down between these. We're going to clean each one out, and we're going to hose it out with hot water prior to putting it back together again. We've also taken out the rear refractory in preparation to clean this heat exchanger. We don't want to get that wet when we're spraying water in here to clean this down after we've brushed it all out. Now that we've cleaned down between the tubes with the proper cleaning brush supplied by the manufacturer, we're just going to gently wash it with some hot water. Most manufacturers supply some type of cleaning tool, and it's important to always use what the manufacturer supplies and recommends. We just recently cleaned a couple of Will McLean Ultra boilers. They had much different style heat exchangers than these. They're constructed of aluminum, and they were plug solid. Somebody was making a half-hearted attempt to clean them with a piece of brazing rod and a hacksaw blade. So we purchased the proper tools, and actually took about 2.5 hours on one boiler to clean it out, but it's now functioning normally again. Most manufacturers don't really recommend that you clean them with anything but hot water, and if they do allow something, it's probably going to be a citrus-based cleaner. Only use what the manufacturer recommends. So we're going to hose this one out to finish the cleanup before we reassemble it. After hosing it down, we're going to give it a minute or two to dry out. We're also going to wipe it down. We want to wipe the back plate. We don't want to reinstall that refractory on a wet back plate, get it wet and possibly damage it. And now's the good time to do the cleaning of the trap. Anything we may have flushed down out of the heat exchanger would have gone into the condensate trap, and we want to make sure that that's nice and clean. So now that we have the rear refractory mounted again, we're going to put the front plate with the front refractory burner and combustion fan back in place. We'll make it sure it seals properly. We'll tighten the 6 bolts, and we'll reconnect the wiring and the gas line, and then we should be good to fire it up again. So we've got it all back together. Turned it on. It's going through initial fire up right now, and the system really has been pretty incredible in this building. There was a 2.2 million BTU cast iron boiler that took up that whole concrete pad, We did some quick calculations based on actual gas consumptions and efficiencies and determined that we'd be more than adequate putting in 530,000 BTU high efficiency boilers. And not that they run at high efficiency all the time, it is a 180-degree water system, so we don't figure 95% on the coldest day of the year. But according to our modulation control, even on a cold winter day at approximately 15 degrees out, we've been down here and these things are cruising along and modulating up and down at roughly a 400,000 to 500,000 BTU input. So I think the savings that they're seeing in this building will certainly, over the lifetime of these boilers, pay it back several times. The return on investment will be great. So that's the brief overview of this system and the cleaning and maintenance for the Viessmann Vitodens 200 boilers.